Greetings! The Master Control program has chosen you to serve your system on the game grid. Those of you who continue to profess a belief in the users will receive the standard substandard training, which will result in your eventual elimination. Tron, released in July 1982, and my favorite hacking movie for its lesson in AppSec attitudes. After all, that's Tron. He fights for the users. Which means this week we have a pre-recorded interview. Our own Paul Asadorian chats with Sean Leach from Fastly about the new mindset we need for web and API security in modern applications. In the news segment, a password manager makes predictable mistakes. Trusted types terminate a vuln class. Printer patches proliferate in our dreams. Scores for software, a folio of fault injections, and more. Rev your light cycle and stay tuned for Application Security Weekly.
This is Security Weekly, for security professionals, by security professionals. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly. Whether you need to manage bots, protect cloud applications at runtime, stop form jacking attacks, or secure your web applications and APIs, only Imperva offers a unified solution to protect from edge to application and data in one tool. Imperva helps you achieve more, save money, and become more efficient with fewer security vendors needed. Start a free trial today to easily protect your apps and website with Imperva. Learn more at securityweekly.com/Imperva. When it comes to web app and API security, the choice is simple. You can choose Fastly's security solution that teams will actually use in full blocking mode, just like 90% of their customers. Or you can stick with costly options that you probably just turn on. You can get Fastly's all-in-one platform that protects apps everywhere they live, however they're built. Or departments can agree to disagree. You can go to securityweekly.com/Fastly to learn more. Or you can just wish you had. Looking to improve your web application security? Probly is reinventing web application security. Probly focuses on the vulnerabilities that matter, eliminates false positives with evidence-based scanning, and provides a simple point-and-shoot solution that is easy to use. Probly's thorough coverage ensures accurate identification of vulnerabilities in any modern web application or API. Improve your web application security processes by visiting securityweekly.com/Probly and start your free trial today.
This is episode 157, recorded July 12th, 2021. I'm your host, Mike Shima. I'm here with John Kinsella. Hello, John.
How you doing? Happy Monday. Long time no chat.
Long time no chat. Happy Monday to you. And it seems like it's been a while since I've seen you, and it possibly may be a little bit of a while could see you in person, because Security Weekly Unlocked will be held in person this December 5th through 8th at the Hilton Lake Buena Vista. Our call for presentations deadline has been extended through July 23rd at midnight Eastern. Visit securityweekly.com/unlocked to submit your presentation. In our July 14th democast at 11 a.m. Eastern, learn how to reveal and protect your entire attack surface. Then join us July 15th at 11 a.m. Eastern to learn how a thoughtful approach to SASE can improve security and enable scalability. Finally, in our July 22nd technical training at 11 a.m. Eastern, learn how guided SaaS NDR enables rapid response. Visit securityweekly.com/webcast to register now. And if you missed any of our previously recorded webcasts or technical trainings, they're available for your viewing pleasure at securityweekly.com/on-demand. And since we have a pre-recorded interview, we're going to play that next. That means, John, you and I get to catch up and chat about the news right off the bat. And it's been 2 weeks since the last episode, so I think there's a little bit of news for us to cover here.
Oh, yeah.
Oh, yeah. So let's see. What are some fun things to start off with? I think one of the things I wanted to get out of the way is just a face-palming event from Kaspersky Password Manager, which was a great write-up here from some researchers or a researcher who went through and found out that in general, password managers are a good thing because they can centralize how all your passwords, make it possible for you to have a unique password for every different website you visit. So all good aspects. Unfortunately, it seems Kaspersky was a little bit more clever than they should have been in how they were generating passwords. And it was just a cascade of errors. So not only were they trying to say, well, we wanted to have password complexity be pretty extra complex and be more difficult to guess. So rather than having something difficult to guess like cryptographically secure random number generator, they went with a random number generator called a Mersenne twister, which, yes, can produce a lot of really great random numbers, but it actually has a state that if you can reverse engineer the state, or if you can sample enough of the values, you can roll it forward, roll it backward, and know everything that was created. It also seeded this entire thing with a time zero, which, and this was the fun part for me, was that basically every second of the day, if John, you and I were click on the password manager and it generated a random and unique password, each of us would have the same nice unique password, thus creating a new definition perhaps of what unique is meant to be. So this was a great write-up, a lot of really fun details in here, a lot of really nice overview. So also wanted to highlight this article just for the way it's written as well. But yeah, I got a 1 facepalm out of 2 out of this, John. I don't know how this rated on your facepalm scale.
It's funny. In honesty, I there was a lot of sort of how would I say, new things to me about this. I hadn't even read the article. I heard about it last week, and I'm like, oh, great. Hey, guess what? Kaspersky has a password manager. Most of us didn't know that. What's interesting is Kaspersky's for a long time was my favorite AV. I think they took a bit of a hit, with their reputation in the U.S. market versus Russia over the last, 5 years or so. But on my work machine, I've got their latest stuff, and man, that does nothing but make my CPU fan go nonstop. So, but that's beside the point. I mean, it's interesting, right? You made it sound a lot more. This is different than when my thoughts when I walked into this conversation was just that they were using straight random number generator, time-based random number generator, and that's it. But they actually tried to do something better than that, and that's more interesting, right? Because that's we're going to have this in a few of our stories here today, I think, where people try to do the right thing or try to do something nifty with security, but as you bring that complexity into something, you're actually not helping yourself. So, good example to use KISS.
Absolutely. And that's one of the things, too, is that I thought this might help us set that theme, kind of as you hinted, for some other articles we'll hit on, because here we have a case of it is in that don't roll your own crypto, which in this case is, as the simple part is that random number generator. And the Mersenne twister, for example, looks great. It's great. It's used for simulations. It's because you also, in some cases, want some predictable randomness, so to speak. So you could rerun simulations under different scenarios. But this is just a great lesson, I thought, in from an AppSec perspective. How would you approach this with a threat modeling aspect in the sense of, well, we want to be able to make these harder to predict, and we want to try to counter the idea of password crackers and the way they're going after this. But then tying that threat modeling assertion into what the code looks like and saying, what are all these weird code smells in here with the poor choice of the PRNG? Also, there was using some floats in there as opposed to integers as it was trying to expand some of the complexity. And floats are kind of a weird presence within cryptographic operations as well. So there's a lot of things that wouldn't pass a code smell, so to speak. And that might be a good tie into things like talking about code smells, talking about scorecards. So there was an article that you highlighted here about scorecard version 2 from the OSSF. And one of the things I thought was great here is that it's measuring not so much specifically of the quality of a code review, but more of the sense of, are you doing a code review, as well as are you doing a lot of other behaviors or processes around the practice of building software. So let me throw it over to you for this. What were some of the reasons that this grabbed your AppSec attention?
Yeah, so the link we have off in the show notes goes out to an article on ZDNet, but then they link out to the actual project on GitHub. And I think what's interesting about this is while it's a CI tool, or it can be used as a CI tool, or whatever CLI type use you want for it to sort of run a scan. It's not doing so much as sort of the standard static analysis which we're used to seeing and thinking about, right? So I hate to make it sound like I was on the leading edge of this thing, but I think earlier this year or last I was commenting that I think one of the areas we're going to see needs to be improved is the security of the build system itself, and that's one of the things the system is sort of working on. So I'm sure they were probably doing it in version 1 too, so it's not new from me. But that concept to be able to go, I had one or two things pointed out here. Let's see. What is the state of the build system? Are you doing best practices in GitHub Actions if you're using that? Are you ensuring that pull requests are required? You can't just merge into your main branch, and that you have to have like a sign off by somebody on that pull request before it can be accepted. So a bunch of sort of good practices, but on the overall state of the system. And I think what's also interesting about this, I think they're mostly focused on GitHub, at least from what I saw, is as we see more and more tools like this out there, it's helping mature the GitHub ecosystem itself without even GitHub having to do the work, right? So you're seeing more and more tools, more and more companies and tools are using GitHub Actions and stuff like that. But as you start a new project and you ponder where to place it, the reasoning behind wanting to do either a closed source system or an on-prem system become less and less versus using some of these cloud Git repo providers. So it's an interesting thing to see how these are becoming, knock on wood, but more and more acceptable.
No, totally. I think without trying to be too clever in my terminology, it's almost like, as you're highlighting the use of GitHub and leveraging its APIs, reviewing it, it's almost like a code as infrastructure, if you will, of just building the tooling around it. And and I think the thing that stood out for me as a scorecard, it's actually measuring behaviors that you want to see and that a DevOps team can actually respond to. Because I've come across and had conversations about scorecards that have focused on, well, you are managing a lot of data or you're interfacing with a lot of other microservices. And sure that, there is risk to collecting a lot of PII data perhaps, or there's a lot of risk to have to interact with a dozen microservices versus, 3 or 4 dozen microservices, but those are sort of more just inherent risks of how applications need to function. And you can't really say, well, we're going to collect less data because that may not work for the way that your application is set up. So big thumbs up for the type of focus that this scorecard is going for, that you can react to it. One of the things that possibly should have been on this scorecard is the practices around checking certificate validation. Once again, some nuances. So this was something that some RPM were making a couple mistakes, weren't they, John?
Yeah, and it's over the years you'll see me roll my eyes and that type of thing around either crypto or certificate management. And this is part of the reason why, right? I mean, this is, again, one of those bugs which has been around for quite a while before we actually, it sort of came to surface here in the last few weeks. But for those not familiar with RPM, Red Hat's package manager, it's used by RHEL, CentOS, probably Rocky, I'm guessing, and a few of these other sort of Red Hat-ish list distros like Amazon Linux and Oracle, and there's a bunch. But as part of that package management, they had the great idea earlier in their existence to, I believe it was initially optional, but be able to check the signature of a package before installing it on a system. Okay, cool. And I think there might be a command in there with the RPM where we can go back and validate the files which were installed, I think, but I'm not positive. But anyways, what they never got around to doing, apparently, was not just when you start dealing with certificates and things like this, right? It's not just, hey, does that certificate match? Is the signature on this package based off that public key signature? Public key. Let's try this one more time and see if I know what I'm talking about. Is the signature on that RPM package valid for this given public key? In other words, do we have that chain of public key cryptography? But then the second part, which they never got around to doing, is that certificate still valid or has someone revoked it? And I believe also they weren't checking expiration, right? So there's a few things around, while they got the main piece in place, as we've seen with more and more either supply chain attacks or other stuff over the last year or so, people are starting to get more creative in how they maneuver around some of these issues. So it came out that this was a problem with Red Hat, or excuse me, with RPM, not doing everything that's needed. And so that comes back to what I was saying around, if you look at some of the more complicated crypto packages, or some of them, complicated crypto algorithms, or even just doing something as quote unquote simple as actual full certificate management and implementation of validation and things like that, they become fairly complex fairly quickly. So I wish there was. This is probably an area. When you were out, we had Clint Gibler on talking about secure defaults. And this would probably be one of those things which would be sort of nice to think about. How can you have your PKI system from end to end actually be secure by default? The words aren't doing me a favor today. But that was my thoughts around this one.
Yeah, no, I think we do have to come up with what a default by secure is going to mean. So that's going to be our homework for this week. But speaking of the last episode, because you also pointed a light to Microsoft had signed a driver loaded with rootkit malware. So it's that's a great, very recent example of a signed blob that you actually want to have a method of revoking. Say that either the certificate is no longer trusted, or the blob signed by the certificate is no longer trusted. So two paths to go down there. But I think fundamentally there's nothing here that to me says, oh, we have to get rid of signing packages, and certificates are too complex, which I'll very quickly admit certificates are complex. Yeah. And especially when we get into the ASN parsing that is part of X509, there are a lot, here be dragons. There's a lot of dangers there in the implementation, but the principles behind it are still good as long as we stick to those basic principles of making sure that we can watch them being revoked. And especially in the web domains, there's a lot of efforts around certificate transparency, so that HTTPS calls can say, has this been revoked, or has a certain has a certificate been presented, but it's only been presented to one subpopulation, subgroup of a browsing population. So there's still some interesting things there to watch for that are well beyond the life cycle of just we generated a cert. So that's how I'm going to belabor that point. Yeah.
Let's talk through that for another 10, 20 seconds. I mean, the reason this bugs me, to sort of spell it out for folks out there, is, as with my developer hat on, I'm lazy, right? I'm usually, unless I just happen to be hacking on something for the weekend, I've usually got some sort of goal, and I'm trying to get that goal done and get something so I can check it off and publish it. So if that's my mindset, and I know that, hey, I've got this package from a third party, I don't trust it, it'd be probably good if I actually make some sort of effort to try and trust that package to see if it's valid before I execute it or install it or do something with it. Hey, let me go ahead and check its pub key and see if that's valid. So that's sort of the train of mind, right? And that's where I'm complaining about wanting to see easier secure by default. Maybe it's part of that function that actually does that comparison. It automatically checks, is the certificate valid? So that's the sort of thought process. I'm using big words and not really going into detail, but that's sort of the heart of it. Is as a lazy person, how can I make sure that my laziness doesn't bite me and everyone else, but I'm actually producing still a quality product?
I agree. I think the friendly way to put that is, I think, as an efficient person. This is so rather than for example, rather than eat our own dog food, we drink our own champagne. Different ways of framing such things, but I think that's a great point, and I'm going to use that to segue into this trusted types report because it speaks to the idea of being lazy, or how lazy can we be, especially if we want to get rid of a vuln class, and we might have to go in do a whole lot of refactoring and migrating some code. So this particular article, well, it's a Google Doc from Google. There's a big surprise, but talking about their adoption of trusted types to get rid of DOM XSS. So already it was nice to see that trusted types, which was introduced, I think, around March 2020. I think that's at least around when we mentioned it once or twice here on the show before. but someone's actually used it. Now, of course, that's someone. There's the caveat is that Google, with a pretty deep budget and for security and for engineering work to dive into refactoring, but for a good purpose. So where am I going with this is that adopted trusted types, which basically says here we're going to decorate this particular input and say we now trust it. So we can focus more on what is the input coming into our application and worry less about trying to enumerate all of the sinks where it might show up in the web app and cause a cross-site scripting and so on. A couple lessons from this that stood out to me was that still a very manual process to do a lot of this migration. So if you're going to refactor, and I think, John, we've probably fall into two different camps of me who loves refactoring and you who might have perhaps a bit more business-focused engineering about we need to ship something new and keep the business running. But they needed to do that time. But it did show that effort paid dividends in the sense that not only did they not have any observed or identified DOM XSS vulns, but it set up their applications so that now it's going to be harder to reintroduce those vulns in the future. So a one-off, pretty deep effort seems to have paid, but you have to be able to have a team and time to be able to do that. So it's not a great world quite yet, but in terms of going for secure by default, if I can remember to say the phrase correctly, getting trusted types in there looks like a positive thing.
Show me the money. That's why we don't do refactors. No, I get that. So I think you're more up to date on this than me. So I'm going to ask you a question actually, which is how does this compare against? I get a general sense of what they're trying to do, and we talked about before. But how in your mind does this compare against, say, like TypeScript, where it's a typed language in the first place, versus trying to? This feels like it's sort of being glued on. Is that an accurate portrayal?
I think it's not so much glued on, as in this is more of a web standard, so you can work with JavaScript natively to get the trusted types. With TypeScript, you have to do that either transpiling or the compiled from your TypeScript into JavaScript. So I think TypeScript, is still a great approach. I think that will also give you actually a richer semantic types to work with. What trusted types do is that you could actually I'm going to hand wave a little bit just how easy it is, but you could actually throw this on from a CSP directive, say we want to enforce trusted types, and it's going to work. It's not going to blow up all of your legacy code that hasn't been decorated with types yet. So I think there is conceptually an easier migration path for the code that you have that you can continue to write and fix or refactor, to use my favorite word of the day, that's already in JavaScript without having to make that decision to say we're going to go into essentially a different language of TypeScript and get into this to prevent these types of vulns. So hopefully that gives you a bit of a nuance there. And one other thing that did stand out, and there was a comment, what did it say? Around 3/4 of the code locations were incompatible with trusted types, could be addressed by mechanical changes to rewrite the code. So that stood out to me as basically it sounds like they've gone through and done rather than a sem-grep type of approach, they've built the AST and then have some tools that say we're just going to automatically walk through the AST and swap out a couple of functions for a different function, basically decorate these things with trusted types, which sounds, one, pretty awesome because you can do that at scale, but also pretty scary because you can break things at scale too. But that just ties into one of my pet loves about dealing with an AST is that not only can you grep and have better scanning, but you can also transform your code if you're willing to potentially step on some landmines.
That phrase, mechanical changes to rewrite the code, that hurts my brain a little bit. But okay, carry on.
I think let's see. Well, I won't hurt your brain. I'll expand your brain in this one. I know actually you and Adrian had a great chat with Clint in going through the news on episode 156, and you did mention defend. I also just wanted to bring up defend so I could basically make a joke about the punctuation-based attack framework to the numeric-based defend framework. But complete aside, as listeners who follow us know, I tend to bring in a little bit of pop culture references every once in a while. And for those of you paying attention to the Defend logo, it does look a little bit Blade Runnery, Star Trek: The Next Generation, kind of that futuristic vibe to it. There's a great website called Typeset into Future. Great blog. Go check it out. It has a fun background, sci-fi typography and design. So there is your non-AppSec topic of the day, just because I wanted to squeeze in a way to talk about Defend. But we are going to bring your brain back, John, and talk about some good things. Good things can happen within AppSec. Here is an article about how we prevented subdomain takeovers and saved thousands. So this, to me, speaks more of just the bug bounty approach to application security, meaning, is your team mature? How mature do you have? Can you approach a bug bounty and your AppSec problems? Meaning, are you just going to turn on a bug bounty, get a subdomain takeover report submitted, then another one, which basically means you're subsidizing a few hundred people, or maybe just a few dozen people, running the exact same tools that you could be running yourself to find these very flaws. And instead of paying a few $1,000s a pop, just do the engineering yourself and fix it as you go. So I think that, to me, is sort of the less about the subdomain takeovers itself, but more about that idea of maturity. And maybe there's a scorecard aspect to that too, about how do you measure this. But that's the positive angle I wanted to highlight from that particular approach.
That'd be I can't imagine anyone actually signing up for this, but it'd be interesting if one of the bug bounty programs set up their payment model from the point of view of, if people keep finding the same thing over and over again, the payout becomes more each time. So maybe, like, say, okay, we did a domain takeover on week 1, and the company marks it as fixed and resolved, and then 3 weeks later someone does one again. That seems like the payout for that should be higher, right? But that's a different topic than what we're talking about here. It just popped into my head. This is one of us has done a talk on the subject, not me. I think what Security Weekly guys has of exactly this type of thing, right? Of, before you just go wandering out into a bug bounty program, do a little bit of hygiene yourself, right? A lot of these are fairly low-hanging fruit that you can go and actually start working on. Or, as in the example I just gave, if someone comes in and identifies an issue within the application, let's push lunch out for half an hour, and let's go and think about where else could this exist within the code. So there's ways to use these type of systems to make huge strides in the overall, not just, as this is saying, not just purely the application security of the project, but your overall the stance of the company. So it's a quick read, but an important one, I think.
Yeah, important one, an important lesson, especially the way you laid it out there. Take that time to look, to ask those probing questions and say, where else might this be? And I think now, unfortunately, John, we have to turn to some bit more pessimism for the day, because speaking of where else might a vuln be, we've got a lot of vulns. And now, this is not the beat up on Microsoft portion of our news segment. It just so happens that Microsoft has a bit of legacy code out there. So possibly going to shotgun a couple different areas, and we'll see which one makes us bleed the most. First, Kaseya. That's ransomware, once again, has been in the news. It's been a little bit being called out as supply chain, but I think just because not every ransomware or every attack that involves a vendor should necessarily be equated with supply chain. But the AppSec angle here that I do want to emphasize is that apparently it was popped by SQL injection vulnerabilities in ASP website. So ancient vulns in ancient technology. So I do think, yeah, exactly. I do think there does have to be a point where refactoring might be necessary to just say, we're going to rewrite our code base into any modern language. And here, I'm not even going to say, well, the only way it could be worse if they rewrote it in Perl, but it could be better by picking pretty much any other language that has a modern framework with parameterized queries, with anti-CSR frameworks, better linting, better static analysis checks. There's a lot of things that could have been better there. So don't know. That's just going to depress me. Yeah.
Yeah, it's so let's take a step back and leave the see if I can start the timers. How long can I go before I start getting grouchy on this one? I think it's interesting from a few different points. It's clear that some of these attackers they're putting their thinking caps on, right? And they're going to go, okay, where can we get best bang for our buck on some of these supply chain type attacks? I know this isn't, at least starting off, it's not one of those. That's where it went in the end. Again, second thing positive. I was talking to someone earlier today, and they were asking me if I thought, the world is really taking security seriously now. And I think when you've got the President of the United States signing executive orders to try and combat ransomware, okay, maybe we're starting to get some serious attention on this stuff. So we can cross our fingers, and I think we're going in the right direction on some of these things if I stay really, really high level. And then we got our buddies writing code in ASP, and so this was a managed service provider, package for a managed service provider. And I've dealt with some of those, not these guys, but different vendors in the past. And I think at the large end, they do a good job. What I've seen like this and I haven't used Kaseya, so I don't want to be completely knocking them. But a lot of the smaller companies, it's sort of like what I was saying exactly with refactoring. Show me the money. If you're a relatively small vendor writing MSP code that someone else will be using, you don't have a large budget to go and do all this type of work that we've been talking about, refactoring or finding the hotspots, and even the last article probably to a degree of is there a bounty program out there that would have had escalating costs? I saw something over the weekend. It sounds like they might have actually known about this vulnerability beforehand, or known of some, but they weren't fixed. So what good is that program if you're not paying attention to it? And then I'll hit the pause button until we hop over to the next story when you're ready.
No, success. We avoided the grouchiness of Kinsella for a Monday morning. No, thank you. But I think that we still got some things that might trigger you. Hang in there. But no, I think to your point, there clearly is a cost. Now, obviously, it's a little bit. It can be a little bit hard to predict. We're going to have a vuln, and this vuln is going to be so consequential. But I think it's a little bit fairer to say we have a application built with some pretty ancient technology that now is incurring extra costs just to keep up and running. You're also going to be challenged to find new hires, people just familiar with ASP who have the insight to say, oh, actually we can do parameterized queries in ASP. This is how you do it. Or we need to get this particular driver to help us out here. Or definitely understand better patterns within it. So you're kind of accruing all this other tech, or this other debt in your sort of, call it your dev knowledge, as well as your legacy tech, that at some point that balance of how much are we going to have to actually pay to get out from under this application? And maybe we should just invest in keeping it fresh, keeping it going. But again, yeah, go ahead.
That's a great point, right? Because I think that's probably one of the, I'm going to say that's probably, if not the one of the biggest critical areas in a modern enterprise that's been around for some length of time is the dead weight from the past. And I think what's going to be interesting over the next year or two, I'm lucky I got in on the GitHub Copilot project. I don't know if you got a chance to play with it yet. It's pretty impressive. Basically using GPT to generate code. And there's some interesting things we could have covered from a security point here. It looks like GPT learned not the pattern of some API keys, but learned the API key itself. So there's some things like that happening out in that space. But from my, bringing it really back to what you're just talking about, who do you get? Because usually a refactoring or something like this, it's not important. You're going to get the new guy on it. New guy ain't going to be wanting to be doing that. He's going to be moving to another company pretty soon. Can you get AI to help you with this, right? So you have these inputs, you have these outputs, the business logic. You just need to really take that thing and handwave here, machine learning, and get it into a new language. From what I've seen with playing with Copilot for, an hour or two, it seems like this is something you could help out with quite significantly. So it's going to be interesting to see what happens around that space.
Awesome. I think my only prediction is that we're no longer going to be blaming interns. We're going to be blaming Copilot for mistakes. So
Totally.
You heard it here first. I think, though, you're hitting a good point there about history. And look, once again, listeners may have noticed I tend to have a few references to the 80s every once in a while, and do go back into AppSec history as well, and trying to make it not just as say, oh, hey, this is what it looked like 20 years ago, har, 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 but more of what are the lessons we can learn. And it was July 2001 that the Code Red worm hit the internet, and this was yet another vuln in IIS that was on the heels of the double decode vuln, which I think we just referenced even last month too. So what was interesting about that is that there was quite a bit of brouhaha around it, around Code Red, and the FBI got involved, and I think the White House got involved as well. And so we have a little bit of 20 years ago, the White House was like, this looks pretty bad. 20 years later, we're actually at the point where software security is bad, but now we actually have some executive orders with some meat behind it in terms of frameworks, in terms of looking at CISA laying out, this is how we want to approach supply chain software. So there's a little bit of the same, but I think we're also in a better spot now. And one of the other lessons I wanted to try to point out is that IIS, yes, we could beat up on it because 2001, horrible year for IIS. 1982, a great year for movies, but I digress. But IIS, or Microsoft, went and actually did a lot of effort and hardened IIS. And then for the next decades, I think it's safe to say, they had an exceedingly rare amount of remote code execution vulnerabilities in IIS, proving that it's possible to harden very critical software. On the other hand, and this is where I'll see where you want to take us next, John, is that just this last month, Microsoft once again dealing with print nightmare and printer drivers. So they've demonstrated that, yes, we can learn from mistakes. IIS can become secure, but drivers, fonts, for that matter, there's a lot of font problems, strangely enough, because the font management gets done within the kernel. It leads to lots of critical vulns. So there's still a lot of things that need to be fixed.
Yeah. I think it's clear. I can't imagine how someone wouldn't consider it clear that Microsoft is picking and choosing where they're spending their security budget.
Right.
At this point, it's the only conclusion I can come to. Guys, fix your shit. And so we have this article here on Print Nightmare, which we're sort of pointing towards this, but in part of my French, this patch didn't completely patch it. I'm not sure if you knew that, Mike. That came out, I think, end of last week. So it's a patch was rushed. The QA isn't there. We're talking about rewriting stuff in Rust and drivers. So obviously, you've got some of the most brilliant people in tech or in InfoSec working on some of these problems, or on problems nearby. Obviously, not this problem. How and this becomes, I guess, a question for the management listening to us. How do you effect the change that you've taken this really great information, this really great wealth of information and research and technology? How do you make sure that travels across the rest of your org? And that I understand, 50,000 employees, blah, blah. But at the same time, Gates in whatever year you quoted, I think 2001, he put his foot down and said, okay, we're no more development, no more feature releases. We have to fix IIS. I'm tired of, being the punching bag. Mm-hmm. And so it's possible to do it. I guess, if I tongue in cheek, we could use your idea of refactoring and just refactor for Windows 11. But yeah, I don't know. This is, again, I think the next year is going to be really interesting. I think we know I tend not to like the big paintbrush of machine learning and AI, but I think a lot of these type of things, hell, we've got the tools already which should have been able to catch us. So you have to at least use the tool on the software. So it doesn't matter if you have AI or not. If you're not running the tool, it's not going to catch stuff. I don't know what to say. I think there's so much good coming out of that company, but at the same time, we see stuff like this. I'm like, that's what makes it hard for me. And I'm trying not to just sound like I'm dumping all over them, but yeah, I don't know.
Yeah, I think
I don't know. Have you?
Yes.
Let's go a little deeper and say I haven't looked at the inner details of this particular issue. I don't know if you have. I believe there's an RCE in there, right, related to this around how you download stuff. So, from an AppSec point of view, can we bring it back and make that into a learnable point for the rest of our listeners instead of just listening to me rant?
I think we all learn from your. It's not a rant; it's educated observations in our spirit of putting positive aspects here. But no, I think one of the things that I did also want to highlight about Print Nightmare is that you're right. Is that the first patch didn't patch because there was actually a vuln discovery / call it a bug bounty as well, kind of collision in discovery here in the sense that, oops, we've got a vuln, need to fix it. Okay, cool. We're going to talk about this vuln that just got fixed. And they're like, oh, wait, what? There was a different vuln that's being released. And so now we have obviously a lot of vulns. I say two is a lot, but consequential vulns showing up in this area of code. So it should be one of those things, to your point, is saying, where else should we be looking, or what can we do differently here to sandbox this better, whether we move it out of, how the drivers, what privileges the drivers have, or harden how they're downloading and being instructed to download arbitrary drivers, make sure they're signed, for example, things like that. Or even, where am I going with this? Oh, even if, for example, on Active Directory services, switch over to things like secure by default and say, maybe our AD, Forest doesn't actually need to print anything. I mean, who can find a printer these days? Well, I think everybody can find a printer, but who can find printer ink these days? It's expensive. It's crazy. But so there's a couple different ways I think you're right that we could step back and rethink how can we approach hardening this ecosystem of printing or this area of software that's more than just make sure everything is patched. So that's maybe the lesson I'd say there. I know we're possibly running to the end of time here, and I did want to highlight just real quick, going to take us a 180-degree turn and talk about a couple of articles from NCC Group about fault injection. So completely different topic, hardware. This is really cool, and I thought a group of 3 articles that were talking about problems in hardware and also finally talking about how you could somewhat address those problems within software while you're going through those long supply chain times of refactoring, redeveloping hardware, fixing problems. But I wanted to mostly highlight in that spirit of it can always be helpful to learn from other domains within application security just to keep your own threat models fresh, as well as just to keep kind of educated on what are the problems other areas of AppSec, in this case hardware, are dealing with, and maybe they can inform some of the areas you want. So not too much time to dive deeply in there, but let's see if there's anything else you wanted to add for some parting words, John.
Yeah. Thank you and good night. No, I think this is so glitching to me is if I had like a week off to go play with my IoT stuff, this is an area I personally would go into. Really super interesting stuff. But I think what the feedback for our listeners is, or the takeaway for our listeners, even if you're not interested in hardware, don't worry too much about grab a coffee or a tasty beverage of your choice, get a comfortable chair, and just sort of browse through this from a point of view of, obviously what they're doing is not close to what this hardware was intended to do. So it becomes almost a threat modeling experiment. I think just read through it, think about what they're doing, how people have come up with completely different ideas, how the simple concept of turning something on and off fast enough can have security implications, and then bring that back to what, not so much how do you turn your own application on and off, but once you're in that sort of thinking outside the box mode, I think there's a good chance you go find some stuff just to think about it in your own applications and what you can be doing or doing better. So I think that's really the takeaway for me on this stuff, beside, wow, that's super cool, they can do this.
It is super cool. And the thing that also I forgot to mention too, has a great concept of reinforcing the idea of fail in versus fail out, meaning you're coming to a security boundary. What do you want your failure state to be? And should that go in, meaning it should, fail secure, or you want to fail out and saying, basically, I'm trying to summarize some really neat insights on ands versus or and logic. But go read the article, because we're running out of time, and I think I'm running out of words as my tongue is starting to get a little twisted too. But this was a great chat. I think we went pretty long, John, but it was a while since we've talked. So hopefully, I think we kept everybody entertained.
I hope so.
Hope so. And I want to say thank you once again, John, for joining me. I want to say thank you to everyone else who's been listening so far. We're going to take a quick break and return with that pre-recorded interview with Sean Leach from Fastly. Please give it a listen, and afterwards, we'll see you next week on Application Security Weekly.
DisruptOps helps you find and fix cloud security issues fast. Getting bombarded with irrelevant alerts is frustrating. DisruptOps gives security and DevOps teams prioritized findings and routes relevant alerts to Slack or Microsoft Teams with automated response options that save you time. Finally, security is inside your workflow instead of in your way. Listeners can access the full platform free for 30 days by visiting securityweekly.com/DisruptOps. We discuss application security a lot on this show, and we know that the implications for code security have become even greater as cloud adoption accelerates software development. Shift Left bridges the gap between security teams and developers to find and fix vulnerabilities accurately from the source. Shift Left Core is an innovation in code security with industry-leading accuracy and speed. It combines next-generation static code analysis, intelligent software composition analysis, secrets detection, security insights, and contextual developer security education in one easy-to-use platform. Learn more and create your free account at securityweekly.com/shiftleft. Are you looking for a solution to protect your web apps against the most business-critical security vulnerabilities? Unleash the power of automated ethical hacker knowledge with Detectify for continuous coverage and relevant security vulnerability findings. Upgrade your web app security with speed and scale and start a 2-week free trial at securityweekly.com/Detectify. Go hack yourself. Welcome, everyone, to this segment today. We are doing a whole series for RSA in Virtual Broadcast Alley. Here with me today is Sean Leach, the Chief Product Architect at Fastly. And of course, the segment is sponsored by Fastly. You can find out more by visiting securityweekly.com/Fastly. Sean is currently the Chief Product Architect at Fastly, where he focuses on building and scaling products around large-scale, mission-critical infrastructure. Sean, welcome to the show.
Thank you very much. Great to be here.
Awesome. And we're talking today about web app and API security, two of my favorite topics. I actually want to start with API security because I think it's really interesting when we think about the modern web app today and how heavily reliant we are both in our applications and services on APIs to talk to basically everything. What kind of challenges do you see today with your customers and with the products as well in facing the API security challenges?
That's a great question. I think in some ways there's a lot of new application architectures out there. And with that comes, the security tools haven't always kept up to speed and kept up to date with those new architectures, right? You think of the things that people are building their applications on today. You mentioned APIs, mobile apps. Those are key for where folks are going. Mm-hmm. Those are 100% dependent on APIs. Then there's a lot of things that APIs power that are somewhat behind the scenes when you think about microservices, like the serverless architecture. You probably heard of the term Jamstack. That's really 100% dependent on APIs. And so when you take the security solutions that folks have used in the past that are heavily focused on web interfaces and web interaction, APIs, the requests look different, the threat models are different, the attack surfaces are different. And so if customers are, with the customers that I've talked to, most of them are heavily API focused. Some of our early customers were like the leaders in APIs. We've really seen them understand and start to focus more on securing those APIs, a little bit different sometimes in their web infrastructure, but they need to still have a cohesive single solution for all of that.
Yeah, I find it really interesting how the architecture has changed over time. I think DevOps was certainly a part of that kind of progression into, I just don't have a web application that loads in a browser and that application goes to a web server that talks to an application server that talks to a database. Our web applications today are talking to all kinds of things. And like you rightfully said, sometimes it's on the client end as a mobile device, and oftentimes it's on the back end. I suppose the first step is understanding and identifying where all your APIs are. Do you guys help with that? Because that's kind of, for me, step one.
Yeah, for sure. We see a lot of people, a lot of our customers have done like tremendous number of acquisitions in the day, right? They've got like 10, 20, 30 companies they're trying to integrate. Every single one of those has their own number of APIs that they haven't itemized in the past. And so we see a lot of people are starting to try and find something they can put in front of those APIs just to provide them auditing and visibility into the APIs that they have. And then these new technologies like GraphQL, like I would say probably a good 50% of our customers are moving to GraphQL as the API technology. REST was the gold standard for the longest time, but GraphQL really allows them to push. Everybody wants to go faster. And so one way you can go faster is to give as much functionality as you can to your front-end developers as they're building web applications or mobile applications, whatnot. GraphQL lets you push a lot of that technology or that kind of data out to those developers. And that's also a completely different way of looking at your API security is GraphQL, because it is different from REST. So not just itemizing them, but itemizing the types of APIs that they have and expose.
Yeah, and for me, there's a couple of basic types, right? There's the APIs that you build into your own applications. And oftentimes, as you well know, and many of our listeners, right, when you build an application, it just gets an API, or there's some program or a library you can incorporate that builds out your API for you, and now your app has an API and it's great. Or you build it by hand, or you're using another service somewhere that provides an API that may be outside of your control. And those are, to me, two different security scenarios, right?
Yeah, no kidding. And like, I think sometimes people forget how detrimental a compromised third-party API can be, right? They spend all of their time focusing on securing their APIs if they're lucky, but then they forget about all those other APIs that, everything, we talk about the microservices and the new architectures and serverless. Everything's composed of many different APIs to build up that experience that your customer sees, whether it is that mobile app or a website or web application. And if any third-party API is compromised, your entire application is compromised, right? It's the weakest link in that regards.
Right. Yeah, it's interesting. There's like completely third-party APIs. I think Adrian Sanabria on our team always uses the Google Maps example, right? It's completely separate, and I call it, and I'm just trusting that like what comes back from them is good or secure or has some type of integrity, right? Yep. But then I also look at the ones in your cloud provider, with our own application. For example, if you're going to transcode a video, like there's an API for that. And you may have some controls over that. So that starts to get into configuration. What should you kind of think about when you're designing your application, ideally at that stage, as to how much work you put into making sure your APIs that are configurable are configured properly if you're not writing them yourself?
It's a tough one. I think that obviously, inventorying your third-party APIs, you can't protect or manage the risk of something you don't know about, right? So obviously, heavy focus on knowing exactly the APIs that you're dependent on, and then understanding the risks of each one of those. And then you're going to have to audit the security of each one of those as well. So APIs have done an amazing job of speeding agility for building web applications and mobile apps and whatnot. It's like unbelievable how cool of an application you can build these days without you having to do a lot, right? Depending, like you said, on Google Maps and others. But you increase your risk when you do that. That's the only kind of thing you really have to concern yourself with is, okay, I'm taking on that risk. It's worth it probably for the speed, but you better make sure your security policies, your auditing, your security, vulnerability checking extends to those third-party APIs too. Yeah,
you're just pushing the type of risk and pushing that risk around, really. Obviously, if I control everything, I control all of the risk and vulnerabilities. But then as I start relying on others, it's still there. It's just, it could be someone else's problem. And where the responsibility line falls is really the question.
Yeah, and I don't think people should be afraid of it. Like, it's, some of the people you depend on have some amazing security teams, probably better security teams than any enterprise would be able to hire on their own, right? Security talent, it's hard to come by. It's expensive. So like not everybody can hire an amazing security team that matches the Googles, the Amazons, the Fastly, et cetera of the world. So it's okay to depend on those third parties, but you have to do your homework and your risk assessment of those third parties. It's just cost of doing business.
What are some of the typical problems, Sean, when we encounter APIs? I think if I had to pick one, it might be authentication and perhaps authorization in there, right? Is that probably the biggest one?
Yeah, I think that's a really common one, whereas people just like expose their APIs and they forget to really provide any level of authorization and authentication in front of it, or they just give a token that gives full authentication and authorization for the API. So really thinking about your kind of role-based access control model that you spent so much time building in your web application, you got to do that for APIs as well. I think that like DDoSes are obviously a big focus or target for APIs just because of how critical they are, depending on what the attacker's goal is. I mean, I think most of the efforts these days, or a lot of the efforts these days, is on ransomware and like application compromise, as opposed to like back in the day when it was really common to try and take something down, right? Take an API down, take a web application down, but that threat's still there. And it can really hurt a business for your APIs being down, considering how much is dependent on them. So really, DDoS protection of the APIs is critical. And then people can try and do application compromises through APIs as well. I mean, the same coding weaknesses that you'll see on a web application for like dumping the password file, the database, a database dump using SQL injection, that can have the exact same attack surface with an API as well. So you can't just think, oh, API, it's new, so it's not vulnerable to those same like attack threats that your apps or your web apps used to be.
when I look at the attacks that are going after APIs, many of them fall into a category or this situation where an attacker is basically able to enumerate things from the API and picking apart like those little pieces of data, like, oh, if I have that piece of data, I can query the API in a slightly different way, and I can do that at scale. I would assume that Fastly has some great defenses against that in preventing that enumeration of the APIs, right? I mean, there's a laundry list of companies that, all dating back to Instagram was one in their password reset feature. Peloton was another that had an open API. And every time I read one of these attacks, it usually comes down to like the attackers on the internet were able to query the API in such a way to be able to harvest information. That seems to me like a solvable problem with technology and rate limiting and being, knowing with signal sciences being incorporated, being able to detect those attacks and stop them.
Yeah, like what we like to talk about is you look at intent, not just like the signature of the attack, right? You think 10, 15 years ago, antiviruses, they were so focused on the signatures of what the malware looked like, but there was hundreds of thousands of new pieces of malware daily. So you couldn't just look to say like, oh, does it match this IP address? Does it match this particular hash of the binary? Right? It was just there was too much. And so some of the new technologies came out that started to look more at intent and the behavior of the application and the client itself to infer intent of were they bad, were they good, right? You're seeing the same thing on the API side and the web application side, where we look at the intent of the request as opposed to just signatures of the request. Intent might be, is this something a human could do? Could they click on a link 1,000 times in a second or something like that, right? Would a human ever enumerate the same username with like 50 different passwords within a certain amount of time, right? Those are things where you have to do that defense in depth model where you look at lots of different attributes of the request. Is it coming from a data center IP? Is it using the right, is the browser signature look right? Is what they're doing on the website or the API what a human would do? And that's where you get true kind of protection against those newer threats that are so good at mimicking real users.
And that's not so much a developer problem as it is an architecture problem, the way you've described it, right?
Yeah, it's architecture, and then it's also just like understanding the application behind the security solution, right? It's like you can't just always put one solution in front of any application and expect it to be great right away. You can start to look and then you can provide some real frontline protection, but really you have to understand the architecture, as you said, behind it. Like, is this GraphQL? Is this a REST API? Where is my login page? Where is my account page, right? You're going to have different protections on your account and login page than you might have on your front page showing like prices of the goods or whatnot, right? So it's understanding that application architecture too.
What can you do to test your APIs before they go into production to kind of minimize some of your risk? And there's been some consolidation in the market, and some begging the question: is it a feature? Is it a full product? What's your take on that, Sean?
Yeah, I think this really lands right square in the DevOps, and also now known as secure DevOps or DevSecOps. Depending on who you ask, it could be one of those two, where the only way you can truly be secure in your application development is to constantly be testing, right? Agile waterfall brought amazing value when it came to constantly pushing code out. Early on with Fastly, we saw a ton of our customers that were the most agile and the most kind of forward-looking and innovative. They were pushing code 10, 20, 30, 100 times a day. They were constantly editing code, testing it, and then pushing it live. That was the essence of the DevOps model, right? Have great tests, have great automated testing, and once those tests passed, push it out to production so you felt confident, making that many changes a day. We're seeing that now on the security side as well, especially around API security and web app security, where not only do you want to test for function of your application as you're writing new code and pushing out new features, you want to test for security as well. Did I introduce any new threats? Did I remove protection of a threat that I used to protect against with a previous version? Then I accidentally, introduced a new vulnerability. So that's where I really see secure DevOps being so great for development teams now, is they can feel more confident pushing code out more often by constantly testing for new threats, for old threats that got through. That's really where we've seen a lot of our innovative customers go to.
Yeah, that's certainly the right approach. In terms of protection, does it sit in line? Does it sit within the application? Like, where do you recommend people start looking at if you're going to implement protection? How do you integrate it into your application?
Yeah, I think it's, defense in depth again. I think one thing you have to do is you have to be somewhat in line, right? I'd say 90% of the traffic on the internet these days is over TLS. So if you're depending on some security solution that sits on some switch or router tap somewhere and is looking at that encrypted traffic, they're never going to be able to see the real threats coming through, right? Especially with a complicated, like a network-based DDoS, sure, maybe, but complicated application layer attacks, they're never going to see that. You have to be in line to be able to spot the nuances of that traffic coming through to really understand their intent. So being in line, I think, is critical at the network kind of like proxy TLS layer. But it's also beneficial to be embedded in the application as well, because sometimes threats, if they can get past the network layer, they can only be seen based on some of the data manipulation that can happen within the application itself. Like you see that with some of the RASP solutions that are out there. You want to be able to verify the security of the code itself, right? That's the defensive depth. Combine the network layer with that application layer to give you the best visibility and then protection from those threats.
Absolutely. You just reminded me of some of the tricks we pull with applications kind of in that light, that if protections are pushed down into the browser, you can ignore JavaScript, for example, selectively ignore JavaScript, right, to get past some of those initial protections, which is really interesting.
Yeah, for sure. We see those attacks now where, like, the problem with browsers and pushing too much protection out to browsers, it's easy to lie as a browser, right? You say, like, but they're using Chrome. Like, they can't lie. Google has written Chrome to be very secure. Well, they've also open sourced it. So someone can pull down the Chromium source code, add their logic in to lie about the user agent. Obviously, that's an easy one. But even like the ordering of TLS cipher suites and everything, like the signatures of the browser itself, a lot of that can be faked, because that's one of the things you have to take into account in defensive depth is you take in signals from the client side, but you have to combine those with signals from the server side and what the intent and the behavior of the entire transaction, because a lot of times that client signal can be falsified.
Yeah. Even with proxies, I think it's Burp Suite that allows you to automatically exclude like field level security and expose hidden fields. And you just automatically, you're lying, whatever, you run it through that proxy and it's just exposing all new things in the application. I think it's a good case for having security in your application and actually seeing those requests to weed them out.
Yeah, for sure. I mean, there used to be able to, like, early on when we were looking for bots, we would just change the DNS record. And we were like, the ones who didn't follow to the new DNS record, those were bots, right? Because they hard coded it. That was an easy one. It's not so easy anymore. Like, people have entire farms of just basically proxying requests through end user browsers without them even knowing. So it looks like a real browser. It's coming from non-data center IPs. They can even manipulate the request pattern so it looks like a real request, i.e. it's not doing something 1,000 times a second. So it's like you have to take into account all of those aspects to truly be able to spot, like malicious intent.
Yeah, it's interesting. That's when behavior detection is super important, because detecting a bot today, like you said, is pretty hard. Attackers are going through great lengths to be able to do that. And so talk a little bit about the bot. You have bot detection kind of baked into the product today?
Yeah, I mean, we're heavily focused right now on account takeover protection. That's where we see the vast majority of quote unquote, the badness that's out there, right? You get a dump from one place and you try that same username password combination at a bunch of different sites in an automated manner, because unfortunately people use the same username and password everywhere. So, step one, don't use the same username and password everywhere. But we do see that as a really common attack methodology. And that's where we combine a bunch of different signals to understand their intent, like data center IP, is their request pattern more often than a normal person would? Are they, attempting the same username and many passwords multiple times? Are they trying different username passwords, right? It's a combination of all of those things that really require that level of in-depth inspection. And you can only see that by being in line with that type of security.
Yeah, it's an interesting example. In the LinkedIn data breach, there was, at the time, President Trump's username and password. And lo and behold, I think it was the second time they broke into Trump's Twitter account. It was the same password as the LinkedIn. They just merely reused it. And that stuff can get kind of tricky. Yeah.
And it's very common. I mean, I look at this a lot with risk, and I see these people like preparing for a nation state to compromise them. Like, okay, I got to have all this amazing security because there's going to be a nation state coming after me. And then they don't put two-factor on their Gmail account, and they use the same password everywhere. It's like, that's why I tell people when I talk to them, like, prioritize your attack surface and the likelihood of that attack, and focus on that, and then move down the stack, right? The very first thing you need to do, just protect your email with proper, email different passwords and two-factor authentication. Don't use SMS, use a TOTP or an app like, Authy or Google Authenticator or something like that. And then walk down, because you can only protect so many things. Like, manage your risk. You're never going to be able to get rid of all of your risk, but manage it with the things that are by far the most common. Because if you look at the vast majority of attacks out there, it's those simple things that get through. It's not some super complex nation state attack that took you down.
It usually comes down to credentials. And it's interesting you give that example, in our own application, one of the ones we'd write internally, we're like, okay, so we can write our own user management, or we can just use Cognito from AWS, and Amazon's probably got a whole bunch of really talented engineers that have put that together so they can sell it as a product and service that you can then utilize. Again, back to the start, right, of this interview, it's a third-party API that you can trust, but likely that's going to be a better scenario and offer better features and address the actual attack surface that you're trying to mitigate against attacks that happen in the real world.
Absolutely. Yes, if you just use some of these third-party services that are critical to your business, that are on companies that are focused 100% of the time on securing these things, you've gone a great step forward, because they focus. Like, Okta has a product out now that's pretty cool. It's around doing your same as the Cognito, your user management for you, right? Instead of you building your own RBAC solution, you can just use theirs. That's actually a partnership that we work really closely with them on, where, because we're sitting in front of so many applications and we see so much badness come through us, we can send them signals from what we see on the internet that they can use in their authentication system, right? That's the whole beauty of the zero trust model that folks are starting to move more and more to, is the authentication identity piece is critical. So as users are using applications, we might say, hey, this client, while it initially looked legit, it's starting to do some shady things. It's dumping database, it's accessing parts of the HR system it's not supposed to. It's trying to dump the database with a SQL injection attack. So we can push those signals out to an Okta or other identity providers where they can force a more in-depth authentication. Say, well, you know what? This client may not be as legitimate as we thought. Let's make them do a two-factor authentication real quick. Let's do a analysis and make sure they're a real end user. That's the next level of zero trust. Not just don't trust the network, but in real time, adjust the trust of the network and the connections over it so you can do more in-depth analysis of those particular clients.
Yeah, and Sean, you're making a great case for utilizing those services such as Fastly and Okta, because if I built some things myself, then I have to tune products to my customization and my customized software, where if I use Fastly with Okta and you folks have already worked together and you've got visibility into multiple clients to collect the data to know what to look for, and everyone benefits from that.
Yeah, you nailed it. If you think of a single enterprise and they're looking at their attacks, they see just their attacks. But the beauty of working with security companies that have visibility across verticals, across geographic areas, they see all the attacks. So if you may not be targeted by a particular attack right now, so you're not going to prepare for it. Someone else might be, though. And so if you use a service that's constantly looking across the attack surfaces, you get the advantage of us seeing those different attack types and preparing to defend against those, so that when the attacker goes to use that attack against you, the customer, you're protected because somebody else already got that thrown at them, and we were able to block against it. So like using third party. Now, don't just trust all of them. That's another thing I get asked is like, well, how do I differentiate a good security solution versus a bad security solution? Well, don't take the marketing, literature for it. Talk to your peers, because you'll find that security solutions, people who love them, people are vocal about it. I know there's this kind of myth, right, that people are like, oh, but nobody talks about the security solutions that they use because the attackers will figure out how to route around them. That's not how it works. Like, attackers are going to go after you even if they know or don't know where your security solution is. But where you can get a lot of benefit is if one of your peers who you trust says, I love this security solution, you should take a look at it. Like, that's way better validation than anything else they can see. You know what I mean? Like any other kind of award or discussion out there. Trust your peers and then test it yourself. Try and break it. Try and get through their defenses. Does it fit into your architecture? Does it slow you down? Those are some of the key things I usually tell people. Absolutely.
And good vendors will welcome that testing and feedback.
Absolutely. And I get asked that all the time, like, oh, well, like, can you just send me a report of your testing that you've done against your solution? I'm like, no, test it yourself.
Yeah.
Like, monitor us, try and break through us. Like this, that's the only way you'll know. Don't take what I said for, that we tested it. Right. Sure, of course, that's a PCI requirement. That's a SOC requirement. We do all these great things. But at the end of the day, the enterprise needs to test it and have that trust themselves.
Sean, that's awesome advice. I want to thank you for appearing on the show today. Encourage our audience to visit securityweekly.com/fastly to learn more. Thanks again, Sean.
Yeah, it was great being here. Thanks so much.